Alright, in this segment, we're going to be solving this quadratic equation right here. You have x squared plus 4x plus 5 equals 0. So if you would, try this on your own, see if you can do it, and just pause the video. Alright, so hopefully by this time you have this problem worked out. Like I said in the last example that I did, I use the quadratic formula, which is, say it with me, negative b plus or minus the square root b squared minus 4ac all over 2a. Now, like I said, I'm going to be using what's called the completing the square method. And so in completing the square method, what you're going to do is basically complete the square. Now, this involves a lot of steps, somewhat, but as I go along, I'll show you the reasoning behind it. It's actually, if you do this method and put the quadratic equation in general form, ax squared plus bx plus c equals 0, and then do the completing the squares method, you'll actually get the quadratic formula. So there's a relationship between the two. The quadratic formula is the shortcut method. Now, if you know the steps to the completing the square method, it will be very beneficial because it makes sense what's going on. So what you're going to do first is get rid of this constant right here, this plus 5. So to do that, you just simply subtract both sides by 5. So on this side, you have x squared plus 4x. I'm going to leave a space, minus 5. Now, the next thing you want to do is take half of 4, and then square it. So what you're doing is you're taking the b, you're halving it, and then you're squaring it. This whole thing. So when you do that, you have b squared over 4. Right? Because you square the b, you square the 2, you get this. But you don't want to do all the work in your head, so you just half this and then square it. What's half of 4? 2. And what's 2 squared? Yeah, it's 4. It's pretty simple. So you just put a 4, so you add 4. Now, since you added 4 to this side, what you do one side, you have to do the other. So you add 4 to this side. Now this is negative 1. Now what's on this side? It's a perfect square. And a perfect square comes in this form. A squared plus 2ab plus b squared. Now, it's a perfect square and with addition sign here. So that's going to simplify, or when you factor it, it's going to be a plus b squared, the whole thing. Now you're purposely doing this when you do completing the squares method. So this will be parentheses, because this is a perfect square. You factor it, you're going to get x plus 2. This will be squared. See why it's called completing the squares? Because now you have a square. And now you want to simplify. But before that, let me point out something. This right here, whatever this number, is always half of b. So if I look at this and I take half of this, just looking at the number, taking half of this, what's half of 4? 2. And it's always half of this. So I have 2, or x plus 2, in parentheses, squared, negative 1. So what am I going to do next? I'm going to square root both sides. When I square root both sides, this actually ends up being absolute value. The absolute value of x plus 2. Let me show you something over here. If I have the absolute value of x equals 5, what's that equal to? Yeah, it's actually equal to plus or minus 5. So when you're doing the completing the squares method, the plus or minus is not popping out of nowhere. It's just the square root of a square is absolute value. So you have x plus 2 plus or minus, and what's the square root of negative 1? I. And then you want to solve for x, you want to get x all by itself, so what are you going to do then? Yeah, you just subtract 2 from both sides. So x equals negative 2 plus or minus I. And if you notice from the other equation, even though there's a lot more thinking involved, there's a lot less steps. And if you notice the pattern, then you can do completing the squares. So you have your x equaling negative 2 plus I, or negative 2 minus I. And that's it. That's how you complete the squares.